Welcome. In this video, we will take a look at the features and controls of Maximus. We'll assume you have a basic understanding of compression and its uses in music production. For an introductory tutorial on compression, see the video info. Maximus is a powerful multi-band maximizer that functions as a compressor, limiter, noise gate, expander, saturator, and much more. It can be used as a per-track effect or a final stage mastering plugin. Maximus takes the input signal and splits it into 3 user-defined frequency bands. Each band can be treated independently. The bands are then recombined and sent to the master compressor. Selecting these tabs allows you to switch the target band. The Maximus interface is arranged into 4 areas: compression envelope, analysis display, band process controls, and band frequency controls. Let's take a look at each of these areas. Maximus is not like a traditional compressor as it doesn't have knobs for the knee or threshold. Instead, it has an envelope that is used to set a threshold, a ratio, or create any kind of relationship between the input and output. This allows for a lot of flexibility on how you want the level to be affected. Each frequency band has its own compression envelope, including the master for a total of 4 envelopes. On the display, the horizontal axis represents the input level and the vertical axis represents the output level. This is a very convenient approach as that is what compressors are all about, input versus output levels. Maximus visualizes that in the envelope itself. The compression envelope has some buttons such as freeze, which locks the envelope from editing, snap, which makes the control point snap to a grid, and show peaks on editor, which enables visualization of the peaks directly on the compression envelope display. There's also a menu with various options for manipulating the envelope. You can find the full documentation for this menu in the FL Studio user manual. So how do you set up the envelope? Let's go over a few typical examples. As the axes show input and output, a straight 45-degree line on the diagonal is no change. For every decibel of input increase, there will also be an equal increase in output. Another way of saying nothing happens. To create standard compression, also known as downward compression, make a control point by right-clicking. This will be the threshold, after which the rate of increase in level will be reduced. The output is therefore quieter than the input. Reference the labels on the display or look at the hint panel to set an exact decibel value. Next, set the ratio by changing the slope of the line to the right of the threshold. The steeper the slope, the more subtle the ratio will be. The area highlighted green covers all the possible ratios for what is normally considered downward compression. The volume reduction gets more dramatic at an accelerated rate the closer to horizontal we get. If we pause it halfway, the ratio is 2:1. For every 2 decibel increase of input, there will be only 1 decibel increase of output. Setting it horizontal would represent a ratio of infinity to 1, also known as limiting. This is because for any increase of input, there will be no increase of output. In a traditional compressor, there is often a knee setting with an option between soft and hard knee. The knee refers to the transition from no compression to compression. Is the change sudden or a gradual, more gentle change? A soft knee is created by rounding the curve. With Maximus, you have complete control over how you want the knee to behave, such as changing the mode of the control point, which affects how the curve shape changes when the point is manipulated. With Maximus, you can do many different types of dynamics processing. Let's look at some more examples. To compress upward, set a threshold point and then raise the lower control point, changing the slope of the line to the left of the threshold. This means that quiet sounds below the threshold will become louder. Imagine watching a movie and adjusting a volume control that only affects the quiet dialogue. You turn it up to hear what the characters are saying, while the louder action scenes stay unaffected, so you don't blast everyone. Both downward and upward compression reduce dynamic range, which is the difference in volume between the quiet and loud sounds. You can also do expansion. If compression reduces dynamic range, expansion increases it. Just like compression, there are two types of expansion: downward and upward. Downward expansion takes quiet sounds below a threshold and makes them even quieter. Gating is an extreme form of downward expansion because instead of making quiet sounds quieter, they're cut off completely. For example, you can use this technique to create a noise gate to fix a noisy vocal recording. This vocal has already been compressed and the noise really stands out. Drifting like a feather on the breath on day. Drifting like a feather on the breath on day. You can adjust the timing of the gate with these controls, which will be discussed later. Finally, some reverb and delay will help mask out the remaining issues, as well as mixing the vocal in with some chords. Drifting like a feather on the breath on day. There are some other methods of noise reduction that might be a better fit for you, but this is one of them. Upward expansion takes loud sounds above a threshold and makes them even louder. With Maximus, you can create combinations of these basic types of dynamics processing. Often, these techniques are combined with limiting to prevent the signal from clipping. You don't have to follow any clear-cut definitions. The analysis display visualizes what Maximus is doing to the sound. When using simpler compressors without visualization options, you can only rely on your ears. This might be difficult as compression effects can often be very subtle and it can be hard to determine if you're moving the knobs closer or further away from your ideal result. Maximus makes this easier by adding in a visual component. Although in the end, listening should always be the primary focus. Is the compression better or worse? Did it solve a problem, or do I like it or not? There are two display modes accessed by selecting the bands or monitor tabs to the lower right of the display area. The monitor display is for observing how the various compression and envelope settings are affecting the output in comparison to the input. The bands display shows the low, mid, and high frequency bands. It is possible to adjust the band cutoff and band level by clicking and dragging on the boundaries between bands or using these knobs here. In the Monitor tab, there are two display options for the input. The first shows the unaltered sound coming into the plugin. The second one displays the low, mid, and high bands, with changes to the pre-gain fader included. The next option shows output peaks for each band. Use this to see the end result of what Maximus did to the sound. The band analysis envelope shows how the input signal is being tracked. For example, altering the attack, release, and sustain in the band process control area is reflected in this envelope. The band gain envelope shows the compression envelope applied to the selected band. By using it, you can see what is happening to the level of the output. If there's no change, this line will be flat. The next option is the same as the previous one but displays all the gain envelopes, color-coded for each band. You can also visualize the pre- and post levels set for the selected band. The speed option adjusts how fast the display scrolls on the Monitor tab. Click the Analysis display area to pause the visuals for a thorough inspection. Finally, you can display a spectrographic analysis of the output frequencies while in the bands mode. It is useful for selecting frequency band cutoffs. From the General Options menu, you can choose a histogram, a heat map, or both. In the band process control area, you can switch between the frequency bands by using these tabs. In general, the controls in this area are separate for each band. They all have their own attack, release, and sustain options, for example. The switch can be used to turn the selected band on. Compression is on and you hear the full effect Maximus has on the sound. Compression off. Compression envelope is off, leaving some other aspects of the band active. The disabled controls will be grayed out. Muted. Mutes the selected band. No sound. Off. Turns the selected band off. You can divide the signal into two bands only by turning either low or high band off. With the checkbox below, you can solo the selected band. The stereo separation control allows decrease and increase of separation, but will only work if the sound already has stereo information. At the center position, the effect is turned off. The pre-gain control adjusts the level of the input signal, which is useful to change the signal relative to the compression envelope's active region, easier than moving the envelope up or down to match a signal. The post-gain control adjusts the level of the output signal, the sound that has already been compressed. Some compressors will refer to this as makeup gain. While the compression envelope is just an instruction of how the output should behave based on input, the band process controls allow you to determine how this instruction should be applied against time. The purpose is to introduce delay to when the compression effect starts and stops and allow for more options to shape the dynamics of the signal. If the change in dynamics is instantaneous, the signal will become distorted. A traditional compressor usually has an attack control for setting how fast the compressor reaches the determined ratio, and a release control for setting how long it takes to return back to uncompressed if the signal falls below threshold. One practical benefit is preserving transients in the sound. Transients give a sound its attack, often described as punchiness or snappiness. By increasing the attack time, we can preserve some of that initial crack of a snare or punch of a kick, while still being able to apply strong compression. Maximus has controls for the attack and sustain, and 2 controls for release so you can customize the shape. Let's see how they work. The attack control has a different function for the master band. If you turn it up, you will notice some latency being introduced. This is because the attack control acts as a look-ahead. The purpose is to allow the compressor algorithm to see the transients before they arrive, so they can be reacted to instantly. As it's impossible to look into the future, real-time processing is delayed so the incoming audio stream can be previewed. The attack control for low, mid, and high bands does not affect look-ahead delay. The release control works identically for all band options. It has an accelerating curve shape. Release 2 has a decelerating curve shape, so it looks like it bends to the opposite direction compared to Release 1 control. When used together, they will interact to create blended release shapes. The overall release curve shape you are interested in will depend on the audio. Sustain sets the duration over which the input is averaged. The effect is to control compressor sustain time and prevent the compression envelope from releasing too early. You can also customize the curve types. The curve types aid in achieving even more accuracy to get the exact envelope shape you'd like. The smaller the value, the steeper the slope. A value of 8 would be a very low slope. Let's do a similar example with the release, which has its own curve type option. A small value, in other words, steeper slope, will make the compression release with a very quick acceleration. Let's turn all these controls to 0 so the compression is instantaneous. As we saw before, the signal will become distorted. This is commonly called wave shaping distortion, and you might already be familiar with it if you've used a plugin called Fruity Wave Shaper. It follows the same exact principle. Note that distortion can also happen even if these controls are set to something above 0, especially with lower frequencies. Let's take a look at the sustain modes. Peak detection is well suited for limiting. This mode tracks the instantaneous peak level of the input signal and will give the fastest detection of transients and therefore the quickest compression response. RMS mode allows transients to pass, but the compressor will still respond to longer duration sounds. The RMS mode is less likely to affect the transients in the original material and results in less aggressive compression. The saturator section has 2 controls, threshold and ceiling. There are 2 types of saturation, A to the left and B to the right. You can use saturation in the master channel to slice off some peaks and improve headroom. Adding a lot can dull the transients too much, but if you keep it subtle, it is practically undetectable and allows you to make the entire master louder later on. The benefit of a multiband compressor is that often the same settings may not make sense across the entire frequency spectrum. A good example of this is a compression technique called deessing. Drops dancing to the sound of my voice, in In vocal recordings, sibilant consonants like the letter S often sound harsh or too loud compared to the rest of the recording. Teardrops dance into the, teardrops dance into the. The S lives in the high end, and with Maximus, it's easy to compress this area individually. You can use the high band alone or set up two compression areas by including the middle band. This way you can choose different settings for the frequencies that sit a little bit lower. The cutoff frequencies for the low, mid, and high bands can be adjusted by using the low and high frequency knobs, or by dragging on the boundaries in the band display mode. The cutoff slopes for the filters can be changed between 12 decibels and 24 decibels per octave. A higher value maintains greater separation between the boundary frequencies. When the linear phase button is selected, low and high filters run in linear phase mode. In this mode, the filters do not rotate the phase of the underlying frequencies, avoiding filtering artifacts. Deciding which one sounds better is subjective. The low, medium, high delay is a look-ahead delay used for the low, mid, and high bands. The purpose is to allow the compressor algorithm to see transients before they arrive, just like with the attack control for the master. As the low, mid, high bands must stay in sync, they require the same delay, so this is a group delay control for all the bands. In total, there are two controls that add latency: the master attack control and the low, mid, high delay. Normally, automatic plug-in delay compensation in the mixer will align the audio output and you won't have to worry about it. Low, mid, high mix is the mix between the unaltered plug-in input and the output from the low, mid, and high bands. Turn fully left to pass dry input to the master and fully right to pass 100% low, mid, high to the master. You can use this control for parallel or New York compression techniques. There's also a separate high-pass filter on the input, which means that this filtering will happen before any compression occurs. The default value is set to filter frequencies below 20 Hz. It can improve headroom without affecting the quality of the audible bass. In the bottom right corner, there are some options for making quick comparisons between settings. Once you're happy with the results, saving a preset never hurts. Now we have covered pretty much everything you need to know about Maximus. Hopefully this video gave you some inspiration on how to use it in your projects. Happy music making!